The next section will be about how to sum the elements by the row. This case, I think it is not that complicated. So do summation on each row of a matrix. The row means this index. We have 1, 2, and 3. Then the row 0 will be 1 plus 2 plus 3. This is 6. The row index 1, 4, 5, 6. Then this 15. And the row index 2 is 7 plus 8 plus 9. Then this 25. Okay. Now, I'm going to make something a little bit different. Okay. So do some summation on each row of a matrix and return the row index which has maximum summation. So after we do the summation, let's check whether the row index 1 or whether the row index 2 or whether the row index 0 which has the maximum summation. So the maximum summation means if we look at this summation, row index 0 is 6, row index 1 is 15, and row index 2 is 25. Then the maximum is 25. And the maximum is 25. It is in the row index 2. Okay. Now, yeah, we are going to make that code. We have the matrix. We have 1, 2, and 3, 4, 5, 6, 7, 8, 9, and then I'm making the row. The row summation. So the maximum row, it means I want to make the first row as the initial value. The initial means I want to make sure that the maximum row has a value at the first time. So the value will be the sum of the matrix at index 0. The matrix at index 0 means the summation of this one. So do you still remember the function sum? Yesterday we learned if we have an array and we use the sum, it means we are going to do the summation of all the elements. So 1 plus 2 plus 3. Then this is the summation of index 0 on the variable matrix 1 plus 2 plus 3. Now we are making a variable index of maximum row. So let's suppose the index of maximum row is 0 for the first time. Okay, because we use the maximum row at index 0. So we make the initial value again at index 0. We do the loop for every row. So for every row means I'm using the row index 0, row index 1, row index 2. And then this will be from index 1 until the length of the matrix. Why it starts from 1? I will check this code. Okay. If sum of the matrix row is higher than the maximum row. What is the maximum row? The maximum row is from this one. It is the summation of the matrix index 0. Then we know that we already calculate the index 0. It means we don't need the index 0. We can start from index 1. We can check if the summation of the index 1 is greater than the summation of index 0, then it means this one is the maximum. If this one is the maximum, then let's change the order. Now the maximum row becomes the summation of the matrix of that row. And then the index of the maximum row becomes that particular row. We can go back to this loop because this is from 1 until the length of the matrix. The length of the matrix is 1, 2, 3. So we can go to the next, which is row 2. When row equals to 2, again, we do the summation. The summation of matrix index 2 is greater than the maximum row. So previously, the maximum row has been updated to the index 1 because the row 2 has more values than the row 1. This is true because the condition is true. Then we update the maximum row. So the maximum row equals to the summation of matrix at the particular row. In this case, matrix at index 2. Then we also update the index of maximum. At the end, we will just print what is the row index where the summation is the maximum. So the index is in the row number 2. Okay, the row number 2 is the maximum index. Okay, I have question. Let's do it together. How to print the sum of the matrix row? So this is this one. So I want to know the summation of the rows. It means I want to print 6 for the row 0, and I want to print 15 of the row 1, and I want to print 25 of the row 2. Okay. Okay, let's do it together. How? We can do this one. Okay, let's suppose we have the matrix equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. When we want to sum the rows, we can do the loop. So let's say row, it is in the row. Is it correct? Let me make by my own. Okay. 0 until the length of the matrix. Oh, I do not want to use the book. Okay. For every row from index 0 until the length of the matrix, so I want to do the summation of the row. Then I can make different. For example, row total. Okay, we can start from 0. Oh, okay. If you know about the sum, you can use some matrix. Oh, okay. The AI knows. Okay. We can do the summation for the particular row of that matrix. And then we can print the row product. For example, row at the particular index row is, you can do like this one. Oh, oh, I missed the comma. Where is my mistake? Sorry. Not changing the row product. Is it right? You need to row product equals to this one. Then we get the value. Okay. So when you have errors and other things, yeah, please do not be so panic. Okay. Yeah, you can take a look where is your error, or yeah, maybe you missed something. You can do like this one. Or if you do not want to use any variable, okay, if you do not want to use variable, then you can just directly sum matrix row. This is also give the same result. So it means you don't need to do another process to get the result. You can just do the summation of the matrix in the particular row. Okay. Now we can do another kind of processing of the matrix. Let's suppose we have two matrices, and I want to do the summation of the two matrices. We have matrix 1, we have matrix 2. The matrix 1 plus matrix 2 equals to matrix 3. So the matrix 3 is, this one is the result from the addition. 2 is from 1 plus 1. 4 is from the 2 plus 2. 6, it is from the 3 plus 3, and so on. So how can we make this one? Then you can have two different matrices, which is matrix 1 and matrix 2. Let's suppose I make that simple, 1, 2, 3, 4, 5, 6, 7, 8, 9. And matrix 2 is 1, 2, 3, 4, 5, 6, 7, 8, 9. For matrix 3, it starts with empty. Now, we can do the for loop. For the matrix, you can see that this matrix is 3 multiplied by 3. When it is 3 multiplied by 3, let's suppose we have matrix A. A 3 multiplied by 3 plus matrix B 3 multiplied by 3. Then the summation will be a matrix and the size will be 3 multiply by 3. Okay, the size of the matrix will be the same for the summation process. It means the size of the row will be the same with any of the matrix. In this case, I'm using the matrix 1. So the range will be starting from 0 until the length of the matrix 1. And then the matrix 3, we need to append one empty row. So this empty row indicates the element in the row. And then we have the append for every of the element. Append of the element in the matrix 3 in the row index 0 means that we have the row column plus row column on the matrix 1 and the matrix 2. And we can have a new value in the matrix 3 in the particular row. And the column will be based on the loop that you design here. So the column will be from index 0 until the length of the matrix 1 in the particular row. At the end, we can just print the matrix 3 and we get this result. Okay, to summation of two matrices, we can get this result. Now, in the matrix, the element, as you see on our example, it is always in the good order. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm going to shuffle. Shuffle, you already learned. Random shuffle or shuffling. Okay. Random shuffling of matrix elements. The elements of the matrix is shuffled to different place. So when we do the random shuffle, means every of this number, it will be relocated. And it is random. Now, how can we do this randomized? At first, we can use the random function. And then let's assume we have this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we have the for loop. There are two for loops. The two for loops means we have the element from the index 0 until the length of the matrix. Okay, so this is the row. And for the column, this is also the row. Now we have the length, which is the length of the element in the particular column. Let me just give a random I, which is the randomize. Okay. This is to make some place for the row, and this is to make a place for the column. So when we do the row and column, we want to replace it with the particular I and j. So for example, I know the column and row, this is matrix 0 and 0. And then matrix I and j. Matrix I and j means a random. And j is also a random. then it can be any number. And we can, let's say, the matrix 0, 0, we have matrix 2, 1, for example. Then it will be equal to the matrix ij, comma, matrix row column. You know how to swap. You still remember? So there is one question in the exam. Okay? When we have x and I equals to I comma x, it means we want to swap the value. The current x and the current I will be updated with now I will be in the x and x now will be in the I. So the idea is the same with this matrix. We have matrix 0, 0, comma matrix 2, 1 equals to, okay. So this one means it goes to the next line. Okay. It goes to the next line. So we have matrix. Let's suppose we have 2, 1, comma, matrix 0, 0. Then the position of the matrix 0, 0, now it will be updated with the position of matrix 2, 1. It will go to this position. And the matrix at the position 2 and 1, it will be updated with the value in the matrix position 0, 0. So it will be updated in this position. And so on. So we will do every of the row and column. And the I and J, it is always be a random value. Okay, so it is always a random value. Then you can get like this one, 362791854, for example. If you do again, yeah, it is a random value. If you do again, then it is a random value. So we call this is the random shuffle from a matrix. Yeah. Okay, next. This question is for your homework. Okay, you have a homework. How to write a Python for matrix multiplication? Do you know matrix multiplication? We have, let's suppose, I don't show it. Matrix A. We have matrix A 2 multiplied by 1. So it means there are 2 rows and 1 column. Then the matrix B should be following the number of column. So it is 1, and the number of column of matrix B can be anything, for example 3. Then the matrix will be C following the row of matrix A and following the column of matrix B. Then it will be 2 multiplied by 2. So let's say we have A is 2 rows and 1 column. 2 rows and 1 column. For example, 2 and 1. Matrix B is 1 row and 3 columns. For example, 1, 2, and 3. Okay. Then the matrix C will be 2 rows and 3 columns. The matrix C, 2 rows. The 2 rows, it means for every of the element, it will be updated from the multiplication of the matrix. So 2 multiplied by 1 plus 1 multiplied by 1 will be the element of index 0, 0. Oh, wait a moment. Oh, no, sorry. I think I made a mistake. So for the in the position 0, so it is 2 multiplied by 1. Okay, 2 multiplied by 1. I make it simple. So for the in row 2, it is 1 multiplied by 1. 1 multiplied by 1. For this position, it is the 2 multiplied by 2. And then for this position, it is 1 multiplied. And for this position, it is 2 multiplied by 3. And for this position, it is 1 multiplied by 3. Okay. This is your homework. Okay. To check how can you solve this one. Okay. Please make it work. So let's discuss it next week together. Okay. Just make it simple with the matrix A 2 multiplied by 1 multiplied by B 1 multiplied by 3. And then you will get the result, a matrix, which is 2 multiplied by 3. 2 is from here and 3 is from here. And for example, matrix 2 multiplied by 1 is 2 and 1. Matrix 1 multiplied by 3 is 1, 2, 3. And this will be the result. Then at the end, you will get a value of a matrix 2, 4, 6, 1, and 2, and 3. Okay, so this is the final matrix. Okay, please try. We will discuss about this next week. Now, I'm going to continue with the second section, which is about two-dimensional lists in a function. When we put the matrix in a function, you can think that this kind of matrix is the same with list. You can think that this matrix is a list. We have a function which is a function to print the matrix. And I have one parameter, which is the matrix. And then now I'm using the for loop. The first for loop is to do the loop from the row. And the second loop is to check from the respective column. And I'm going to print for every row and column and give the space for every of the element. Once I print the column, I will go to the next line. Let's suppose the matrix is this one. And I'm going to print the matrix. So the print matrix is the function name, and matrix 1 is the variable that we use to define the matrix. Now let's see. We can make a function, and this function use one parameter, and this parameter is from the matrix. Second one, we have a matrix. And let's suppose I want to create matrix. And because creating the matrix require some tests, for example, yeah, I can do the random. Then I want to make it as a function. So whenever I want to create a matrix, just call the function. The function name is create matrix. Given the matrix, okay, so you can, yeah, for example, define the matrix at the first time, or if you do not want to define the matrix at the first time, you can create an empty list from this function. The number of rows, it means the input from the user, how many rows do you want to create, and the number of columns, how many columns that the user want to have the column. And then the remaining is the same with what I explained to you previously. So we do the loop from the index 0 until the number of rows. For every rows, we append one new empty list. After we have a new empty list, then we can go to every single value in the column. And then we will append a new value randomly generated into this particular row. After we finish with this loop, then we will return the matrix. So the create matrix, in this case, the matrix is not necessary, okay, because we are creating a new matrix. At the end, after you create the matrix, then you will print the matrix one. Enter the rows 2 and then enter the columns 3. Then you will get the value 7, 13, 49, 50, 48, 20. It is based on the random values. Now let's see with the example. Okay. We have one example how to do a program for grading. Okay. Write a program that grades multiple choice tests. Multiple choice. 객관식 문제. Okay. Given the keys and the student answer, show the student's score. What is the keys? Okay. The keys are the correct answers of 10 problems. So we have the keys. So this is the correct answer. Now let's suppose the multiple choice, we have the choice whether it is A or B or C or D. All the students' answers are stored in the matrix students. So we have students and we have a matrix. Okay, this is a matrix. So this row means the student 0. This row means the student 1. This row is the student index 2, and so on. Then we have 1, 2, 3, 4, 5, 6, 7. So there are 7 students. The student 1, this is the answer of the student 1 on every question. So this is the answer of student 1 on question number 1. This is the answer of student 1 on the question number 2. This is the answer of student number 1 on the question number 3. Number 4, number 5, number 6, number 7, number 8, number 9, and number 10. And we need to check if the student's answer is the same as the key, then it gives score 1. So we need to check. The student answer, problem number 1 is A. But the correct answer, the key is the correct answer is D. So A equals to D. No, then 0. What about the second problem? B. B equals to B. Yes, then the score is 1. D equals to D. Yes, then the score is 1. Then 1 plus 1, it is 2. C and C, okay, 1. C and C, okay, 1. D and D, okay, 1. B and A, no. B and C, no. C and C, 1. C and D, 0. Then the score of student 1 is 1, 2, 3, 4, 5, 6. So the score is 6. So how can we do this one? So if the student's answer is the same as the key, then it gives score 1. Otherwise, 0. Okay, so I give you the solution. Let's check one by one. We make a function, calculate score. And I have one parameter, which is the students. So the students, I want to put it into here. Now let me make a new list, student score with an empty list. Do a for loop from I in the range of the length of the student. The length of the student means we have 1, 2, 3, 4, 5, 6, 7. Okay, there are 7 students. Then the range will be from 0 until 6. Now let's set up the score equals to 0. For the student number 1, let's check. For j in the range of the length of student I, it means I'm going to check one by one from the data of student I. Student I means the student index 0. So there are 10. Then I'm going to loop from 0 until 10, or this is from 0 until index 9. And then I need to check if the students in the index I and j, which is this one, index I and j, equals to the keys index j, equals to the key index j. If this one is true, then add 1 to the score. So we do this loop until all elements on the student at index I. After we check all elements, then we put the score. Okay, we put the score into the list student score. Okay, we put the score which using the append into the variable student score. At the end, we will return the student score. So the student score will be 7. So this is index 0, 1, 2, 3, 4, and so on. So this is the final score. Print calculate score with the value from the student answers. Okay, so we have the keys, we have the students, and then calculate the score. So the score is this one. Then student 1 or student index 0 got the score 6. The student at the index 1 get the score 7, 4, 4, 9, 6, and 5. I think I will stop here because I need more time to explain this one. Let me continue next week. Okay.